Hi dear students, Santosh here, and today I am going to deliver my lecture number 3rd on water quality standards and water treatment processes. It is very important lecture as far as water supply engineering is concerned, and I am once again requesting you to subscribe my channel if you are really interested in civil engineering and MPSC and other competitive type of examinations, as well as these lectures are very useful for diploma as well as degree level students to learn the subject online or through YouTube. So let us start my lecture. First of all, we are going to discuss the water quality standards. The water quality standards are divided into 3 categories: the physical standards, chemical standards, and bacteriological standards of water. And these are suggested by following agencies: Indian Council of Medical Research, that is ICMR committee; World Health Organization, that is WHO International Standards; United States Public Health Society, that is USPHS; American Water Works Association, that is AWWA; and Environmental Hygienic Committee. These are the committees or organizations who are suggesting various physical, chemical and bacteriological standards of drinking water or water. Then we are going to discuss the physical and chemical standards of water. The first physical standard for turbidity, if it is measured on JTU scale, that is acceptable level is 2.5 and cause for rejection is 10. Then color is measured on platinum cobalt scale and acceptable unit is 5 and cause for rejection is 2.5. For taste and odor, the acceptable is unobjectionable. That is very important. For taste and odor, the acceptable is unobjectionable. Then pH value is acceptable, that is in the range of 7 to 8.5. Total dissolved solids mg per liter are 500 for acceptable, 500 that is mg per liter, and cause for rejection is 1500 mg per liter. Then total hardness mg per liter is 200 is acceptable and 600 is cause for rejection. For chlorides it is also 200 for acceptable water quality and 1000 mg per liter is for cause for rejection. Fluorides 1 and cause for rejection is 1.5. Nitrates 45 and the cause for rejection is also 45. Then calcium mg per liter, that is 75 is acceptable and 200 mg per liter is the cause for rejection. So you people must remember all these values. All these values are useful for competitive type of examinations, and you must remember all these values because these values are frequently asked in competitive type of examination. So please go through all these values. These values are important. And for bacteriological standard, guideline values for bacteriological quality, that is number per 100 ml is guideline values always 0, and for coliform organization third time it is 3 in some cases and it is 10 in unpiped water supplies. For bacteriological standard, the organisms are divided into various categories. First is the piped water supplies. Second is untreated water entering into the distribution system. Third is the water in the distribution system. Fourth is the unpiped water supplies. And last one is the emergency water supplies. And for that organism, it is divided into 2 or 3 categories. That is fecal coliforms, and second is coliform organism, and third is also coliform organism. And the guideline value is always 0, and in the remark you can see that turbidity is less than 1 NTU for disinfection with the chlorine, pH is preferably 8, free chlorine residual is 0.2 to 0.5 mg per liter following 30 minutes contact with the water. So you must go through these guidelines. Okay, these guidelines are very important. Then we are going to discuss the virological aspects, that is 0.5 mg per liter as discussed earlier of free chlorine residual for 1 hour is sufficient to inactivate the virus even in water that was originally polluted. So the dose of 0.5 mg per liter of free chlorine is sufficient to kill the viruses. This free chlorine residual is to be insisted in all disinfected supplies in the areas suspected of endemicity of infectious hepatitis to take care of safety of the supply from the virus point of view, which incidentally take cares of safety from the bacteriological point of view as well. For further areas or for the longest areas, 0.2 mg per liter of free chlorine residual for half an hour should be insisted. So free chlorine is very much essential to avoid the virus infections through water, and 0.5 mg per liter dose for 1 hour is sufficient. After that we are going to discuss the water treatment processes. The purpose of water treatment is to remove the suspended, colloidal and dissolved impurities which are objectionable either from the taste, color and public health point of view. So why we should treat the water? We should treat the water to make it fit for drinking and remove the objectionable material from that. Okay, and that objectionable material is in the form of suspended, colloidal and dissolved impurities. First of all, we discuss the screening. Screening is to remove the all floating matters or materials from the surface water. It is provided at the intake point. There are two types of screening. First is the coarse screening and second is the fine screening. Please look at this figure. Figure shows the various screening. The screening here, the inclined screening is provided. We can see this inclined screening. Then we should see the arrangement of inlet and outlet for that water from the screening plant, and there are provision of operating platforms also to collect the waste, coarse waste also. There is a provision to collect the coarse waste. Then second treatment after screening is the aeration. It is one of the most beautiful treatment of water supply engineering. Aeration is to remove the objectionable taste and odor, to remove the dissolved gases such as carbon dioxide and hydrogen sulfide, etc. And also the iron and manganese are also oxidized in some extent. So we can sprinkle the water into the air and air will do the trick and remove all the objectionable material. It reduces the corrosiveness and increases the pH value of the water. And the types of aerations are free fall aerator or gravity aerators. Name itself indicate it is free fall or it is gravity fall. Second are the spray aerators. There is a spray. And third is the air diffusion basins. These three types of aerations are used. Please look at first figure, that is cascade aeration. There are steps and steps are formed for the aeration of the water. Second is the inclined apron aerator. The inclined apron is there and there is a provision of ripple and plates are also there, and there is a provision of inlet trough and outlet trough. And this third one is the air diffusion ventilator is there. There is a lifting lugs are also there, removable panels are also there. There are several trays are placed and there is a collector plan also, and there is a arrangement of inlet and outlet. And these three types of aerators are used for aeration purpose. After aeration, the third treatment is sedimentation with or without coagulation, coagulants or coagulation. The purpose of sedimentation is to remove the suspended impurities. With plain sedimentation, silt and sand can be removed. And sedimentation with coagulants or coagulation removes very fine suspended particle and bacteria. And types of sedimentations are plain sedimentation, and second is the sedimentation with coagulation. It is very simple. Plain sedimentation is used to remove the silt and sand, and sedimentation with coagulation is used to remove the finer particles. On the surface of the finer particles, coagulants are there, and they increase the weight of that finer particles and allow them to settle down in the sedimentation tank. That is sedimentation with coagulation. And without coagulants, there is a sedimentation in the plain tank. It is called as a plain sedimentation. Please look at this figure. This is the plain sedimentation tank. First is the plan, and this is the cross-sectional or cross-sectional elevation. The sludge is collected at the bottom. Inlet is at top, outlet at the bottom. The second is the sedimentation with coagulation. There is an inflow is also there. There is outflow, and there is an inlet zone, outlet zone, and in the tank there is a sludge zone and also settling zone. So please observe these figures and please study these figures for the competitive type of examinations. This figure is very important, that sedimentation with coagulation, and all the time asked in the competitive type of examinations with that particle and their velocities and how they settle in the sedimentation tank. The direction of flow is also important. Then we are going to discuss the filtration. It removes very fine suspended impurities and colloidal impurities that may have escaped from the sedimentation tank. The microorganisms present in the water are largely removed. Filters used for filtration processes are slow sand filter and rapid sand filter. The comparison of slow sand filter and rapid sand filter is very important. The figure and their working and their operations are very important. But in this lecture, I am going to discuss only broad aspects of every process, so we can discuss all these processes in my further lectures. But you must remember that after sedimentation or after sedimentation with coagulations, there are certain fine impurities and bacteriological impurities or microorganism present into the water, and we can remove that microorganism or fine particles with the help of filtration. It may be a slow sand type filter, it may be a rapid sand type filter. Okay. So please look at the arrangement of that filters. Water is there, below water there is a sand, below sand there is a gravel, and under drains are provided there. And second figure is rapid sand filter, and in the rapid sand filter also there is the arrangement of gravel, and filtration water storage tank is also there. So you must study all these figures and operations for the water supply engineering. Slow sand filter and rapid sand filter. There is always one question in all type of examinations. So you please study the slow sand filter and rapid sand filter very elaborately and descriptively. I am going to describe the same in my further lectures. Then fifth process is disinfection. It is carried out to eliminate the removing microorganisms, bacteria, some of which may be pathogenic, to prevent the contamination of water during its transit from the treatment plant to the place of consumption. So even though there are some bacteria present after filtration, we can kill that bacteria or remove that bacteria with the help of disinfection. So disinfection is also very important, and we do disinfection with the help of chlorine and other chemicals. Then there are some miscellaneous processes also. This process include the water softening to remove the hardness of the water, desaltation of the water, then removal of the iron and manganese also, and other harmful constituents. So you must study all these miscellaneous processes also for the water supply engineering, and that miscellaneous processes are also important and nowadays that are practiced in any water treatment plant. Please look at this figure. This figure shows one typical water treatment plant. The raw water is entering into the screening. After screening, there is a preliminary settling tank. After that preliminary settling tank, the water goes into the still well. After still well, water goes into the aeration fountain. After that aeration fountain, there is a chemical mixing of water. Then after chemical mixing or mixing with the coagulants or disinfectants, there is a flocculation channel is there. After that flocculation channel, clarifiers are there to pure the water or to treat the water. After that clarifier, water goes to the filter. The filter may be a slow sand filter or rapid sand filter. After that filtration, water goes to the clear water sump or in the pump house. From the pump house, water is transferred into the overhead RCC reservoir, and after transferring that water into the overhead RCC reservoir, water is supplied to the distribution network. This is the typical line diagram of any water treatment plant, which is elaborated here to describe all the different types of processes on the water. So this is enough for that my introductory lecture, and for more details you may contact my administrator on 9822604968. My email ID is there, svkulkarni72@gmail.com. You can make queries or you may contact me on that email. Till then, goodbye, and please do not forget to subscribe my channel. Okay, bye bye, bye, see you, bye.